Okay, I'm Matt Bauhoff, Associate Professor in the Petroleum and Geosystems Engineering Department and at the University of Texas at Austin. This is part 4 of our Matlab review, which involves programming in Matlab. So the major topics we'll be talking about today is script files and function files, both of which have the extension .m. They're both .m files. And then we'll continue on to more traditional programming techniques like for loops, while loops, if statements, and a few other similar techniques, and we'll do some examples with that. So this is really the tough part of programming. This is real programming now. We'll be writing some code, learning how to do that, and hopefully we'll have some good examples to go along with it. So as I just mentioned, there are two types of .m files. You both open them the same way, but one is a script file and another is a function file, and they are very different in how they are used. Script files are a lot like the command window, or what we were calling the interactive mode. In a way, they're just a piece of paper where we can write down a bunch of different commands. The nice thing about the script files is that we can save the file, we can edit it, we can change it. We don't have to deal with the prompts. We can write as much as we want and then run the program, so it's a program. So it gives us more flexibility to do more. Function files are like black boxes. We call function files. Where we run script files, we call function files. That's the big difference. So function files usually have a specific job to do. I like to use the analogy that function files are a lot like a punter on a football team, is that they have a very specific, important job to do. They stay on the sidelines. When they're needed, they are called to do that job. They come in and do their job, and then they go back to the sideline. That is how a function file works. It's got a very specific, important job to do, but is not part of the main program until you call it. Usually you send it important input variables, and then out come output variables. And we'll already talk about some function files, but we've already been using a lot of built-in function files in Matlab. One of them is reshape, fopen, fscanf. A lot of these that we've been using are built-in function files, and they've been used that way. We don't even know what the code is or how it works. All we know is we send it some inputs, and output comes some outputs, which is exactly what we wanted it to do. The important thing with a function file, and I'll talk more about that, is the first word of a function file is always function, and the name of the function file has to be the same as the function name. That's very, very important, and we'll go into more detail about that. So what are script files? Script files are just a sequence of statements. It's kind of like on a big piece of paper that we write what we're to do. And so they are very much like the command window. And in fact, it's connected to the command window. So anytime I run a script file, any variables I define or calculate inside the script file immediately get dumped into the command window. So if I define x is equal to 4 in the script file and I run it, then I can type in x in the command window and it'll say that x is equal to 4. And that's what I kind of said right there. So those are some side effects, right? So if I run it, then it shows up in the command window. I can, as we talked about before, I can use comments. So the percent symbol, the green percent symbol, is a comment, and Matlab ignores it. They're just for you and me, so that we know what we're talking about. So good programmers always do use a lot of comments. They explain what the program does so that if you come back a year from now and you forget what you did, you've got some words explaining what exactly you did it, or if a new user looks at it, then they know exactly how it was done. So let's talk about creating a script file and opening an M file. So I can go back to Matlab, and I'm in there. Let's make sure I'm in the right document that I want to be, right file. So I'm going to go back to what I was in before. So you can be in whatever folder you'd like to be in. Okay, and remember, we're in the command window, or the interactive mode. What we can do, there's a few different ways I can do this. I can click on this button right here, so it says New Script, or I can press Control-N. That would work. Or I can go to File, Open. Well, I can probably do File, New Script, or Function. Actually, when I do it, I just do a script, open it as a script file, whether it's script or function, then I define it as a function if I want to do that. But let's just do script files. So you can see this is just white space, right? So I got all these lines, and I can do whatever I want. So I can define things like x is equal to 4. I can do y is equal to 5. And I can do z is equal to x plus y. I can put a comment, calculate z, misspelled it, calculate z is equal to x plus y, right? And that's the, I can write as many commands as I want to on here. I could do plots if I wanted to. I could create vectors. I could say u is equal to 4, 5, 6, just like we did before. V is equal to 1, make a column. So that's u and v, all right? So I just got a bunch of commands, and I can do as much as I wanted over here. And so now you see it's untitled. I got to save it. So I can save it as whatever I want to call it. I can call it file name my first program. Okay. Now it's saved as my first program. And if I want to run it now, what you have to do is you have to go into debug. You can do run. You can go to debug run. I could click F5, or I could click this green arrow button. Any of them work. Okay. A lot of times I just go up and do that, but you could have clicked F5, any of those, and they'll run the program. And then you'll come over here, and hopefully you won't have any errors. So if I did something wrong, I might get an error, and then I got to go fix it. In this case, it doesn't look like I got any errors. And if I type in whos, look, it says U, V, X, Y, and Z are all in the command window because I defined them in the script file. I ran it, and I'm in the same folder as what the script was in. So if I type in U or V, then they're all there. Okay, so X, Y, U, V, they're all in there. So I can, and then I can do things with them if I wanted to. I could say X plus Y plus Z now if I wanted, because all those are in there. So the command window is directly tied to the script file I run. So I created a script file, I ran it, it dumps in the command window, and then if I want to do things in the command window with those things, I can. But a lot of times the goal will be to write everything you want to do in the script file. So you only have to do it once. You run it, and then if next week I want to run the program again, I do it again. Maybe I change some variables. Maybe I do some other things. So that's how a script file works. I could do plots if I wanted. I could, I could say x is equal to 0 to 100, right? Y is equal to 4 times x. Plot xy and use black dash line. Now let's save it, run it, and look, so a plot came up, right? If I go into here, and here's another thing. So I defined x is equal to 4 there. This is probably bad programming practice, and I used it, and then I defined x as a vector, which is completely different. So x wiped it, this new vector wiped out the old scalar. That probably wasn't a very good idea to do it that way, but that's how Matlab reads it. It thought x was equal to 4. It did some stuff with x. Later on, I redefined x as a vector, and it did that. So, so if I go back over here, I bet it tells me it just thinks x is a vector. It forgets that x was equal to 4 because I wrote over it. Okay. So back to my slides. All right, we talked about how to open an M file. So you can do it by doing File, New M file, or you can do File, click Open that. And here's an example of a script M file, just like you did over there. I'm not going to type it out. If you want to do it, you can, but it was very similar to what we just did, right? I define, in this case, I've got a lot of green comments. As far as MATLAB is concerned, they don't even exist. They're just for you and me. Okay, and for anybody else who wants to look at my code. The only thing that MATLAB sees is this stuff in black and purple there. And so x, y, we define those. And then we did x times y transpose. So it does matrix multiplication. So that was a 2 row by 3 column. And then I transposed y. So it was a 3 row by 2 column. So I bet x times y, if you type it out, x times y transpose will be a 2 by 2 matrix. And then maybe print a comment. fprintf, just like the command window, and all that stuff will show up in the command window if you go look at it. Okay, so that's how script files work. There's nothing special about script files. They're just like the command window. They're just a nice way of putting all your commands in one place, saving it and running it. Okay, when I write a big long program, there'll only be one script file. There'll only be one. Now there might be tons of function files. There could be 0, there could be 1, there could be 1,000 function files. Function files are code that communicates with the command window and other functions using a predefined list of input and output parameters. If you've ever coded in a different language, you may have called them subroutines or modules, something like that. They're called functions in Matlab. And this is very, very, very important. The first line of every function file looks exactly the same. The first line starts with the word function, lowercase, F-U-N-C-T-I-O-N, function, and then it has whatever outputs there are, okay, and they're in brackets, and however many outputs you have. You could have 0 outputs, that's possible. You could have 1 output, you could have 100 outputs. And you separate those by commas. And then that's going to be equal to the function name. So maybe the function name is my first function. Okay, or maybe it's Darcy law, or maybe it's calculate y, or whatever the name of your function is. And then in parentheses, not brackets, but in parentheses, you put all of your inputs. And those are separated by commas. Now, when I used to teach the course on computer programming, I would give problems on tests, and I would ask that the student write a function file. And if the problem was 20 points, I would give them 5 points just for getting the first line of code right. So if they wrote function, the correct output parameter list in brackets is equal to the correct function name, and put their correct inputs in parentheses separate by commas, that would be 5 points out of 20 or 25, no matter what they wrote after that. That's really important, I think, to get that first line of code right. Okay, and if you get that right, then it kind of sets up the rest of your function file. Okay, so in important notes, some of which I already mentioned, the first word is always, 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 always function in a function file. The output list is optional, okay, and when I say optional, I mean it's possible you don't have any outputs. Might be a somewhat boring code, but you have some, you have your output list, and it's in square brackets, and if you have multiple ones, then they're separated by commas. Now, if you only have one output, you don't technically have to put the brackets, but I do it anyway a lot of times just to be consistent. But if you have more than one output, then you always have to have brackets and they have to be separated by commas. The function name absolutely must be the same as the file name. So if the file name is myfirstfunction.m, then the function name is myfirstfunction. Okay? Notice the distinction there. You don't put the .m in the function name. Okay, I mean, in the function, the first line. So if the name of the file is myfirstfunction.m, then you just put myfirstfunction right here as in the first line of code. But it must be exactly alike. It is case sensitive, so if you use lowercase everywhere, etc. Be careful when you do these function names. Don't ever start a function name with a number or a symbol like the pound symbol. You'll get an error, and you might not know why. It's confusing. Just start it with a word. You can use numbers later on, or you can use different characters inside the function name. Just don't start it with like a pound symbol. That's not gonna fly. The variables, the inputs can be numbers, right? So X, Y, Z. They could be a vector. They could be a matrix. They could even be a string. They could be you put that in apostrophes. So they could be. It's very flexible with the kind of things that you could do. I like to think of function files as black boxes. I call a function file. Remember, I run a script file. I call a function file. And when I call a function file, I send it inputs. It does something. It does some sort of job, and then come outputs. Think about one of the function files we've already used. Reshape. Reshape we didn't write ourselves. Somebody that worked for Matlab wrote the reshape command, but it was a function file. We don't know how that code works. It might be really complicated. It might have 100 lines of code in there. We don't care. All we know is we sent it some inputs. We sent it the original matrix. So we did things like we would say B is equal to reshape A 2, 6, which meant we want to send A as an input. We want to send 2, which is the number of rows, as an input, and 6 is the number of columns as an input, and the output was B, which is the output, right? So we sent it some input parameters, and out comes some output parameters. Here are some really easy examples. You might want to do this yourself. So you might want to pause the tape and actually create a function file that looks like what I have on the left. So I open up, a new file, and I write function SP. So S and P are my outputs, right? Is equal to add mult X and Y. So X and Y are my inputs. The name of the file is obviously addmult.m. It has to be, because remember, the name of the file, addmult.m, has to correspond to what I put in the function line, which is addmult. It's got to be case sensitive and everything. Okay? And then it looks like what this function file does is it does two things. It calculates S, which is the sum of X and Y, X plus Y. That's why we use S for sum. And then P is equal to X times Y, which is a product, X times Y. That's why I use P for product, although I could have called it whatever I wanted to. So I send it X and Y, and it does two different operations. It adds them together, and it multiplies them, and I calculate S and P. So that's my function file. Now I want to call my function file, and I can do that from any number of places. You can call a function file from the command window, which is what I'm suggesting you do here. You could call it from a script file. So you could have a script file where you write, where you define some variables, and then you call addmult, and then it does the operation, send it back. You can even call a function file from another function file. So a function file can call a function file, and that function file can call a function file, and it can do that. So you can call a function file from any of those things. Let's just do it in the command window or the interactive mode. Here we define two variables, A and B. So we say A is equal to 4 and B is equal to 5. Now let's say I want to add those two things together, and I say 4 plus 5, and I want to multiply them together and do 4 times 5. I mean, I could just do it in the command window, but I've got a function file which does those two things for me, so let's call it. All right? And I want U to be the addition of those two, and I want V to be the multiplication of the two. So I'm going to call addmult, and I'm going to send it my inputs, which are A and B. Those are 4 and 5, right? A is 4 and B is 5. And the outputs I'm going to call U and V, which are going to end up obviously being 9 and 20. So I do that, and I call it, and it does that. Now, the very key things here is that you notice that A and B are different variable names in X and Y. That's okay. Okay? I defined A and B as 4 and 5. It knows that, and it knows that the first argument there corresponds to X inside the function file. It knows the second one, B, must correspond to Y. Then, using X and Y, it calculates S and P. Then when it comes back over here, S is the first output, which is now U in the interactive mode, and P is the first output, which is V in the interactive mode. Okay? And if I wanted to, I mean, I can, well, so I'll let you do that, and you can try some different things. And one of the things that you'll notice is that now it knows that U is equal to, when you run it, okay, or I'm sorry, when you call the function file, addmult, it calculates U is equal to 9 and V is equal to 20, and it knows what that is. Now, it will not know what S and P are. S and P are defined in the function file, and that's a key difference from a script file. That's a very, very key difference from a script file, in that in a script file, anything you define in there and when you run it, it gets dumped into the command window, and it knows all those variables. When you call a function file, it doesn't know all the stuff that's inside the function file, all the stuff in here. All it knows is the outputs, which we define as U and V. So it knows what A, B, U, and V are. It does not know what X, Y, S, and P are, or anything else we define in there. Now, I didn't put a semicolon here, so when you call a function file, I bet that P shows up and it says P is equal to 20. But that's just a printout. It doesn't actually know what P is. In fact, if you retype P, it'll give you an error and say, I don't recognize P. So try it. So try it. Write this little function file, which is only 2 lines of code, and then type these things in. Try some different things. Type S, P, X, and Y and see if it knows what it is. It won't, but it will know what A, B, U, and V are. Okay. So I just did some really, really simple things, and as I mentioned before, I think one of the most important aspects of writing a function file are getting that first line of code right. And remember, you can have any number of inputs and any number of outputs. You could have 0 inputs and outputs. You could have 1 input, 1 output, 8 inputs, 1 output, any different combination. So here's a case where I have a function 4x plus 2, okay, and the first line of the function file would be function, whatever the name of the m file, so I called it matsfunc.m, so it's matsfunc, and then the input, and I called it alpha, right? So I could have made it x, I could have made it alpha, it doesn't matter, as long as I'm consistent in there. And then I would write something in here which would say f is equal to 4 times alpha plus 2, because alpha is what the name of the input file is. Then when I call it, I would say matsfunc of 4. Right? 4 would correspond to alpha. Keep in mind that this would probably be a poorly written code because I've got no outputs in this case. So even though it would calculate f, it wouldn't send that information back to the interactive mode. Okay? Here's a case where I say g is equal to 2x squared plus 3y squared plus 4. So I've got my output, which is g, or I called it z here. Again, I'm kind of being arbitrary on purpose, okay? So changing variables up just to see how that works. And I called it new function, and my inputs are x and y, because it's got to have 2 inputs. So then I would write an equation there that said z is equal to 2x squared plus 3y squared plus 4. And then when I called it, I'd have to define what x and y are, but I could say new function x and y, or I could have called it a and b. I could say a is equal to 2, b is equal to 3, and say new function of a and b. And then the output is not z, I call it p, but it knows when I run that z corresponds to p. And I give a few other examples over here. So the important thing is that the way that it's structured, the first line is function, outputs in brackets separated by commas, is equal to the name of your function, and then inputs in parentheses separated by commas. And these variables here are used inside the function file. So x, y, and z are obviously used to calculate f, g, and h. When I call it, these variables don't have to be the same as those. These variables don't have to be the same as those, but they correspond to those, right? All right, so here's an example of a function file, and I recommend that maybe you pause the tape and just write it out. So this is a really simple function file. Function net, so that's like net for a budget. So you send a budget, you can send your wage, how much you make per hour, how many hours you worked, what your monthly rent is, your food per month, what your tuition you have to pay is, and the amount of money you spend on gasoline per month. Right? And you do a little calculation. So your income is your wage times your hours. Your expenses is your rent plus your food plus your tuition plus your gas. And the net is the income minus the expenses. Okay, and then I wrote some comments in there. And then you could do you can call your function file. So in your command window, you could call budget, and you could send as inputs your wage, your hours, your rent, your food, your tuition, your gas. And regardless of what variables you use in your command window, what you call these things, you've got to define them, and you send it, and then what comes back is net. You could even change that so you put net, comma, income, comma, expenses. That way you would know all those things. So, you know what? I'm going to do that. I'm going to open up a script file. So I'm going to clear or a function file, excuse me. I'll do it for you. So function net budget wage hours rent food tuition gas. Say income is equal to wage times hours expenses is equal to rent plus food plus tuition plus gas. I'm going to say net is equal to income minus expenses. And I could put I could put comments below it if I were to decide if I wanted to. I'm not going to. I'm going to save it, and I've got to save this as budget.m, right? Because this is budget. Now MATLAB's really smart. It knows this is a function file, and it knows it has to be called budget.m, so it automatically does it. So I can just save it. Okay? Don't change it. MATLAB had it right. Okay? Don't change it to something else, then it's not going to work. Okay? But budget, it's going to be budget.m. I'm going to save it. Now I've got a function file called that. So I can go to my command window. And I can define all those things. You know what? But I'm not going to call it wage. I'm going to call it W. I'm going to say my wage is $15 an hour. Okay? And then I'm going to say that my hours, I'm going to call it H instead of hours, is, let's say I work 175 hours in a month. My rent, okay, let's say that that's $500 for the month. My food, $200. My tuition, say I pay only $300 a month. And gas, I spend $50 a month. Okay, I'm just making up numbers. Okay, I know I'll use G here for gas. Some of them I use the same variable, sometimes I didn't. It doesn't matter. Okay, and I'm really lazy. So I'm going to go over here. And I'm just going to copy and paste this. Okay, but it doesn't know what wage is. It knows what W is, so I'm going to use W. I'm going to use H. Oh, I did call it rent. I called it food, tuition. I called it G. So those are the variables I'll use there. I don't have to call it net. I can call it what's left over. Or savings, maybe. That's what my savings is for that month, right? And I call it, and there you go. I got $1,575 of savings, right? Well, if I asked it a few things, if I asked it what net is, it gives me an error. Because even though it called it error in here, it called it net in here, that's not what I called it in the command window. I called it savings. So it knows what savings is. It doesn't know what net is, right? And that's one of the differences between a function and a script file. It knows what W is. It does not know what wage is, all right? What about income? It doesn't know what income is because it wasn't an output, and it was just defining. So one thing I could do is maybe I want to know what my income and my expenses were. So I could put, income, or I could call it, call it whatever I want. Expenses. Oh, yeah. So I got an error because they weren't outputs in my function file, but maybe I should have made them. Okay, now it knows all that. So it says my income is $26.25 for the month. My expenses are only $10.50. And so that's why my savings were the difference, which is $15.75. So that's a really easy function file, but it kind of gives you the idea of how they work, right? So in general, we're going to write a lot more complicated function files. We'll do some things, but that's just a practice of how we do some of that stuff. Okay, so now we know how to do function files. We know how to do script files. Remember, there's only one script file per program. You write a script file and you run it. A function file can be called from a script file or a command window or another function file. You can write a script file and call hundreds of function files if you wanted to. Okay, or you can call the same function file over and over again with different inputs. You can do all that. So let's go on to some real programming now. And the first thing we're going to talk about is relational operators. Okay, a relational operator is a comparison between two variables, and the result is either true or false. So you get a positive integer like 1 if it's true, a 0 if it's false. So just go to the command window and type this in. A is equal to 2, B is equal to 4. And, well, you can just type in A is less than B, so I can do that. So what if I said A less than B? What I'm doing is I'm asking it a question. Is A less than B? Well, the answer is true. It is. So I get a 1, which is a positive number, right? Because that's a true statement. Okay? I could have called it a variable. What was I? I would say A is smaller equal to A less than B. Okay, I got 1. So the variable A is smaller. A is smaller than B, so I get 1. Now, what if I said B is less than A? Well, I get 0 because B is not less than A. B is bigger than B. So B is bigger than A. So that is not a true statement. It's a false statement. So all we did is we tried a relational operator there. What about, there's a bunch of other ones that we can do. That was a less than, greater than. Some of those are pretty obvious. So this is less than. What if it's less than or equal to? You could have done that. A is less than or equal to B, or greater than B, or greater than or equal to. Here's a good one. This is equal to. Okay? When we want to check to see if A is equal to B, we don't say A equals B, because that would make A equal to B. What we want to do is we want to check to see if A is equal to B, so use a double equal sign. And that's important. The double equal sign is a relational operator. It checks to see if A is equal to B. It doesn't make A equal to B. The little squiggly line there, which is usually on your keyboard, it's one of the kind of the top left of your keyboard. You got to use the Shift command. So it's right next to the number one on your keyboard. You do the squiggly and then you use the equal sign. That means not equal to. So you'd be saying, is A not equal to B? Right? And so in our case, A was 2, B was equal to 4. If we said A not equal to B, then it would say, well, yeah, that's true. It is not equal to B. This is the and symbol. So you can do, well, is A less than B and B less than C? Well, if we could do that, and it would only come back true if both statements were true. So if A was less than B but B were greater than C, then it would say false because only one of those statements were true. Alternatively, you can use a straight line, which, let me see where that is. That's usually above your enter sign, below your backspace. So it's and you got to use shift again. And that's the straight, and there, that's an or. So you could say A less than B or B less than C. So if only one of those statements were true, then it would come back true. And then we already saw this logical, this squiggly, which is like, not equal to, right? So let me do some more examples there, I think. Let's go to the command window. I'm going to clear all. CLC, and we'll say A is equal to 2, B is equal to 4, put a semicolon there, and C is equal to 3. So, and I'll do one more. I'll say D is also equal to 2. So what if I say A is equal to 4? Well, it says no, it's not. A is not, or I could say A is equal to D. I could say A is equal to B. It's not. A is equal to D. It's true. Well, what about A not equal to B? Well, A is not equal to B. A is 2, B is 4, so that's going to come back true as well. We can say A is less than or equal to B. Well, that's true. A is less than or equal to D. Well, they're both 2, so it is less than or equal to. So I think that's going to come back as true. Let's see, what else can we do? Okay. Let's use the and. So A is less than B, and B is less than C. A is less than B, that's true. B is not less than C. So it's going to come back 0. A is less than B, or B is less than C. That is true because A is less. Only one of those conditions has to be true, and one of them is. So then it comes back as 1. All right. So there's some relational operators for us. I really do hope you're following along here. You're only going to get anything after this if you just follow along as I do. Okay, where are relational operators important? They're important in if statements. And if you've ever played a video game or computer game in your life, then you're very familiar with if statements, because that's all computer games are, is if statements. You know, if the user presses the X button, then the player jumps. Or if the user presses the triangle button, then he throws a punch. Okay? That's how a computer game works. It does something based on if you do something, right? So, computer programs are only good if they're allowed to make choices, right, based on what something is. And the way we sort of think of this is that we say, if something is true, do this block of statements. And if it's not true, then don't do it at all. Just skip that, right? So, here's a simple example. I can say, if A is less than 0, display A is negative n. So maybe go over here. I'm going to clear all again, start from scratch. And I can say A is equal to -1. Okay, and then I can say if A is less than 0, enter, display A is negative. And I got to always put it, every if statement's got to have a corresponding end to know that we're ending the if. Okay, A is less than 0, so it should do those commands. It should display A is negative. There we go. Now let me define A is equal to 2. All right, so now A is 2, and I can just do the same thing I did before. I'm going to use the cursor up, I guess, here. If A is less than 0, display A is negative n. Okay, it didn't do anything because it looked and it saw that A is not less than 0, it's greater than 0, so it didn't do the commands that I asked it to do between the if and the end at all. That's how an if statement works. Okay, you can do a lot more stuff. Okay, well, what if this is true? So, you know, you can do, if this is true, then do this block of statements. Else if, so if it's not true, but something else is true, do the next set of statements. And if the next set is true, then do the next set of statements, etc. Okay? Now, what's really important here is that it kind of moves in line. So it sees if a certain statement is true. So I say if this statement is true, it does that block of statements. If it were true, then it goes all the way to the end. And it skips everything else. Okay? So it's not going to do all of these things. It's only going to do the first one that's true. So if this is not true, but then this one is, it does this block of statements. But then it gets done and it goes all the way to the end and it doesn't even read what's over there. That's a very important point. So it's possible that the if, else if could all be true statements, but it's not going to do all those block of statements. It's only going to do the first one. Let me give you an example. Okay? Here's a code how we set this up. We say if x is greater than or equal to y, c is equal to x squared minus y. Else if y divided by x is greater than 0, c is equal to log of y over x, and then you end it. So I've got one else if statement. You can have 0 else if statements. You can have 100 else if statements. You can have as many as you want, so you don't have to have any. The previous example we had on this page here, we didn't have any else ifs. Here we've got one. I could have 2 or 3 or 4 or 10. Okay, but important thing is you say if an expression, you have your commands, then you have else if your expression, and then your block of statements or commands, and then you end it. So I'm going to ask you to do this problem. I don't want you to type it in. I just want you to think about what the answer would be. So why don't you pause the tape? Well, look at these 3 questions and pause the tape. Write down with a pencil and paper what you think the value of C would be in these 3 different cases. Okay? So pause the tape and come back in just a moment. So now that we're back, hopefully you have figured out. So what if x was minus 4 and y is minus 3? So x is greater than or equal to y. That is not a true statement. Minus 4 is less than minus 3, so it absolutely does not do that first thing. y divided by x is greater than 0. Negative 4 divided by negative 3 is 4/3. That is greater than 0. So then c would be the log of 4/3. And we know log actually means ln in Matlab, so it's the ln of 4/3. So whatever that is. Okay, what about the second one? What if x is 4, y is 3? X is greater than y. That's true. So then c is equal to 4 squared, 16 minus 3. So c should be 13. Okay. The next statement, y over x is greater than 0. It's true that 4 over 3 is greater than 0, but it never even sees that command because this statement was true. And remember, it goes as soon as it finds something that's true, it does those commands and then goes all the way to the end statement. So it doesn't do c is equal to log of 4/3. It never even sees that command, even though it's a true statement. What if x is minus 4 and y is equal to 3? Minus 4 is not greater than 3. Okay, so it doesn't do that. Y over x, minus 4/3 is not greater than 0, so it doesn't do that. And then it ends it. So it never calculates c. So unless I calculated c somewhere else, if I did this loop and then I ask it what c is equal to, it would give me an error and say it's undefined because it never calculated c. It never got past the if or else if statement to look at the statement, so it doesn't ever calculate c. So that's what happens in those three cases. Now, that's else if. You can also have an else statement. Okay? And an else statement means anything else. All right? It means if anything else is true, do something. So you can have an if statement. You can have as many else if statements as you want. 0, 1, 2, 3, up to 100. But there can be a maximum of one else statement. You can have none, but the maximum you can have is else. Because else means anything else. Okay? And notice the key thing here. We have if, and we have some sort of expression that we're trying to relate. X is greater than y. Else if y greater than x is greater than 0, is that true? Else, we don't write anything after an else. It's the last thing. It's anything else. Okay? So, in this case, we say, if x is greater than y, c is equal to x squared minus y. Else if y over x is greater than 0, c is equal to log of y over x. Else, print this statement, which is either x and y are both negative or x is less than y, and we've got a problem. That's what that else is. Okay? Or I could have said else c is equal to 0. I don't know. Whatever I wanted to do. Okay? But this is an important point here, and I see people make this mistake all the time, which indicates they just don't understand how if-else statements work. And the mistake they make is that they will put some sort of statement after else. That doesn't make any sense. Else means anything else. So you don't put else y is greater than x squared. You don't write that because it's anything else. And you can only have one else statement, and it's always the last one in that string. You've got if, else if, else if, else if, else if, else if all these things, and then the last thing is else. Do this, end. So that's how if statements work. Let's do a little example. Let's do an example. Now I want you to do this on your own. I want you to write a function file called rolldice.m. that randomly chooses, let's see what I want to do here. A number, integer, so it's got to be an integer, between 1 and 6. So between 1 and 6. So what we're doing is we're trying to simulate rolling a dice, right? So if anybody ever played the board game Risk, and most of you probably do it on a computer now, so if you ever played the board game Risk or any computer game that involves rolling die, what you have to do is you roll a die, and it randomly gives you a number between 1 and 6, right? So how does that work? How do they write a computer program to randomly roll a die? Is there somebody inside the computer monitor that's actually rolling a die? Of course not. They are writing a computer program which randomly chooses a number between 1 and 6. Okay? So here's what I want you to do. Step 1 is to write the first line of your function file. This is a function file. We want to call it rolldice.m, and we want the output to be an integer, and the output is going to be, we'll call it iDice, okay? And in this particular case, there won't be any inputs. So stop the video, write out what you think the first line of the code is, and then turn it back on, and I'll show you what I have in my first line of the code. Okay, so now that you're back, it's function. That's always the first line, right? Outputs in brackets. I'm going to call it iDice. You could have called your output whatever you wanted to, but the important thing is that we do that, and because there's only one output, you don't technically need brackets, but I recommend you do it. The name of the file was rolldice.m, so this is going to be rolldice. And the inputs, well, there's actually going to be no inputs in my file. That's how I don't think there's no need for an input the way we're going to do it. So maybe you did have inputs. Maybe it would work. I'm not sure, but I didn't need any. So my first line is function iDice is equal to rolldice. So if you were taking my programming class, I would give you 5 points on the test just for writing that. That's it. Okay, now the next step is that what do we want to do? Let's think about it. What we want to do is we want to randomly choose a number between 1 and 6. Now we know in Matlab how to do random numbers, right? You can use the rand command, and rand will give us a number between 0 and 1. Okay, the problem is that we want an integer. We don't want a number that says 3.43 or 0.57. We just want 1, 2, 3, 4, 5, or 6. So maybe what I can do is I can write a code that gets a number, maybe not between 0 and 1, but between 0 and 6. So I have to scale it. And then what I can do is that if the number is between 0 and 1, I say that the number is 1. If the number is between 1 and 2, then iDice is equal to 2. If the number I get is between 3 and 4, then I get the number 4. So pause the video again and come back in a minute and tell me what you get. So here's how I did my code. What I did, I'm going to cheat a little bit here and look at what I wrote. The first thing I did is I created a number. It doesn't matter what it is. I call it X, you call it A, you call it B, whatever. Is 6 times rand of 1. And there's more than one way to do this, by the way. So just because you got something different doesn't mean it's wrong. But I said X is equal to 6 times rand of 1, which means that X is a random number between 0 and 6. Because rand of 1 would have given me a random number between 0 and 1. This is going to be between 0 and 6. What I'm going to do is I'm going to say if X is less than 1, iDice is equal to 1, right? And then I'm going to say else if X is less than 2, iDice is equal to 2, else if X is less than 3, iDice is equal to 3, and I'll just show you what I have here. This is what my code looked like. And I do X is 2, X is less than 3, X is less than 4, X is equal to 5. Here I could have said else if X is less than 6, iDice is equal to 6. That would have been fine. I wrote else iDice is equal to 6. Either one would have been fine. Okay? I could have done it like that. I like the way I did it, but it doesn't matter. You may have done it like this. I just wanted to show you how to use else ifs and else together. But notice there are 1, 2, 3, 4 else if statements. There was only one else statement, and then of course the whole if structure ends with an end. That's the important thing there. Here's something else to notice. If x is, let's say I get x is equal to 0.53. Okay? If x is less than 1, I dice is equal to 1. Okay? 0.53 is less than 1, so I dice would be equal to 1. 0.53 is also less than 2, so does that mean I dice is equal to 2? Absolutely not, right? Of course it's not going to be less than 2, because once it sees that this is true and it does this, it goes all the way back down to the end command. Right? So let's see if how that works. You go to my Matlab command, and I think I've got it. So you should oh, I don't have it. I gotta have it somewhere. Maybe it's in here. Oh, there it is. Roll dice. Okay, good. So let me file, open. That's got to be in examples. Roll dice. So it's the same code I showed you a minute ago. So it's there. Now I'm going to go to the command window, and I think I was in the. I got to change my directory now. I'm going to go to. There, that's an example. CLC. Okay, and what I can do is, if I want to call it, I can say iDice, or I can call it something else, you know. Random dice, whatever. I don't have to call it the same thing as the output in the file. Is equal to roll dice, and there was no inputs, remember. And this should send back a number between 1 and 6. Okay, I can keep calling it. See, it keeps on giving me a different number every time, but it's always an integer, and because I use those if statements. Now, there's probably other ways you can do that. I bet MATLAB's got a way of calling a random integer, but they probably wrote a code to do exactly what we just did. But this is a kind of an example of how you use if statements. Okay, so let's go and let's learn some. Oh, I closed out my. Okay, loops. Loops is what most people find pretty difficult. But once you learn how to do them, you know how to do them. It's kind of like riding a bike, okay? So what a loop is, it's a way of repeating the same task or a similar task over and over and over again. So that's what we do in computer programming. We want to do a calculation thousands or millions or billions of times. You don't want to write the same code a billion times in a row and do a same calculation or maybe a slightly different calculation every time. It would be easier if you just said repeat it. You repeat it so many times. Okay, and there's two and that's what a loop does. A loop just loops around and keeps on does the same one until you tell it to stop. Now, there's two kinds of loops. One of them is a for loop. One of them is a while loop. Okay, and they have some similarities. Sometimes there's ways of interchanging them. So You might be able to rewrite a for loop as a while loop, and it does the same things, but you'd have to change some things up. Although most problems are kind of more intuitively fit as a for loop, and others fit better as a while loop. Okay, I like to give the analogy of a for loop as running around a track. Okay, or both of them actually as running around a track. The way a for loop would work is if I said, run around the track 10 times. That's a for loop, because you know exactly how many times you want to do that loop. You want to do it 10 times. Run around the track 10 times. Okay, if I said, okay, I'm going to start a clock and run around the loop while the clock, the timer, is still under 15 minutes, then you wouldn't know how many times you're going to be able to do it, right? You're just going to start, and you're going to start running, and then when the clock stops, that's the last time you're on the loop. It might be 8 times, it might be 12 times, it might be 10 times. It depends, okay? That's how a for loop and a while loop are different. Okay, a for loop tells you exactly how many times to do it, while you do while some condition is true. So the for loop is always for something like an index, and I like to use I or J or K, something like that. By the way, I do this a lot. I'm going to do a little side kind of thing. Good programming practice says that variables that are integers we start with the letters, start with I, J, K, L, M, N, and maybe O. That are real numbers. You do A through H and P through Z. You start with that. Okay, now some languages like Fortran and I think C++, you have to do it that way. Like if you start a variable with the letter M, so if I say mat is equal to, it has to be an integer. And if you started a variable with the letter A, then that would have to be a real number with decimal place. You couldn't write A is equal to 4, you'd have to write A is equal to 4.0. And believe it or not, in Fortran and C++ and some languages, you'll get an error if you do otherwise. So if you want A to be equal to 4.0 and you say A is equal to 4, it'll give you an error. Lucky for you, in Matlab, it's a little bit more forgiving. So you can say you can make A a real number or an integer. You can make N, something that starts with N, a real number, an integer. It's not a big deal. However, from a good programming practice standpoint of view, it's still good to start off integers with letters that do that, and real numbers with variables that start with those letters. So you'll see me usually do that. Okay, sometimes I don't. Sometimes I say x is equal to 4, but for the most part, I try to do that. Okay. So back to over here, we got our for loop. We'll get a while loop. Let's start talking about for loops a little bit. For loops. And you should go type these in. And what I would suggest is you type them in as script files. So here's a case where I make x a vector. And I say x is equal to linspace 0 to 100. So that's x is a vector, which is 0, 1, 2, 3, all the way up to 100. And then I have got a for loop. So let's just, I'm going to write it actually out here. So we do. Okay, and let's actually go over to Matlab, and I probably should do this in a script file. I can do some of it in a Yeah, that's what I thought. So it doesn't exactly have exactly 100 elements. It's got 101, so it's well, it's got 100 elements, so it's actually doesn't space by ones. It's 1.01. So what linspace looks like is this vector. Let me go back to over here. So here's my code. Don't pay attention to that top part. So got the bottom part there. X is equal to linspace 0 to 100. Sum x is equal to 0. So what this means is I've got 0, and then I think it's 1.01, 2.02, something like that. I probably should have gone from 0 to 99 or something, but you know, all the way up to 100, right? That's what x looks like. Then what I want to do, what this loop does, is it says sum x is equal to 0. So at this point, I got a variable, I call it sum x, and it's equal to 0. This is looping through, and it's saying for k is equal to 1 to the length of x, x has got 100 elements, so you can say for k is equal to 1 to 100, sum x is equal to sum x plus k. So what this for loop means is that I'm going to start, that's kind of, when I say for, okay, that's like programming jargon for start. Start at k is equal to 1 and end at k is equal to 100. So k is equal to 1, then k is equal to 2, then k is equal to 3, then k is equal to 4, and then k is equal to 100 when it ends up. Okay? And then when k is equal to 1, it does sum x is equal to whatever sum x was plus x of k. Then k is equal to 2, and it does sum x is equal to sum x previously plus x of 2. Then it does k is equal to 3, okay, and it proceeds to continue to do that way. So in this case, sum x was equal to first 0, so and then k was equal to 1, and then sum x was equal to 0 plus 1.01, which is equal to 1.01. Then k is equal to 2, so sum x is equal to sum x plus x of 2, which was 2.02. So I would probably get 3.03, etc., and you go all the way to k is equal to 100, or the length of x, right? And then it ends it. That's how a for loop works. What it does is it just keeps on doing the same command however many times I told it to do. So in this case, it went from 1 to 100. I could have said, go 1, 2 to length of x. Well, what would that have done? Okay, it means space it by 2. So first k is equal to 1, then k is equal to 3, then it's 5, then it's 7, then it's 9, then it's 99, and then it would stop at 99 because it would just skip over 100 and it won't do 101 because it never goes past 100. So that's how that would work. Okay. No, let's go here, back to here. Don't need that anymore. Let's go, yep, let's go here. Okay, here's another example of a for loop. In this case, I say for y is equal to 0 to pi and increase by increments of pi divided by 15. So that means start at y is equal to 0 and end at pi, but go by increments of pi divided by 15, right? And then in each case, the command to do that is display whatever the sign of y is. So it'll display the sign of 0, sign of 0 is 0, then display the sign of pi over 15, then display the sign of 2 pi over 15, then 3 pi over 15, until it gets to 15 pi over 15, which is pi, and then it do the sign of pi, which is also 0, and then it's done. So it continues to do that loop, you know, a set number of times. So we know exactly how many times we're going to do it in advance, and because the increments are pi over 15, we know we're going to do it 15, or I guess that's 16 times, right? In this case, we did the loop exactly 100 times. That's why it's a for loop. Remember, go back to my analogy of a running around a track, right? So when you run around a track, you do that a set number of times is what I told you a for loop is. And that's different from a while loop, which So those are some examples of for loops. This will be a good opportunity to do another good example. So let me give you a little bit of background. A tridiagonal matrix is one that's square and it's got elements on the main diagonal and it's got elements to the left of the main diagonal and to the right of the main diagonal. And it's got zeros everywhere else. Okay, so an example would be, let's just make it all 2's on the main diagonal, make it simple. And then make it -1 to the left and the right. And zeros everywhere else, right? So you got 0, 0, 0, 0, 0. And this is a 1, 2, 3, 4, 5, 6. So this is a 6 by, this should be a 6 by 6 matrix. So 1, 2, 3, 4, 5, 7. Oh, it shouldn't be there. Okay, so it's a 6 by 6 matrix in this case, but it could be any size. In this case, we're saying 2's on the main diagonal, like -1's on the off diagonal, and that's a tridiagonal matrix. So what I want to do is I want to write a function file. So write a function file called tridiag.m that when sent inputs in computes an n by n tridiagonal matrix called T. So that's our output. So I want you to write the first line of the function file. Go. Pause the video, come back when you've got it. So now that you're back, first line of the function file should be function T tridiag n. That's all you need. This is the input. I sent an n. N being the size of the matrix. It could be a 6 by 6 or 6,000 by 6,000. We want to keep it general, and it's going to compute the tridiagonal matrix T. Okay, and that's what our function. It's the first line of our function file. Okay, step 2 is now I want to create that matrix. Okay, and what we're going to do, and I'm going to keep it simple. We're just going to say that the main diagonals are 2 and the off diagonals are -1. We could make it more general, include more inputs, and do that, but let's just keep it simple for now, and we'll do that. So the main diagonals are going to be 2, the off diagonals are -1. Okay, this is a little tricky, so let's take it in steps. Okay, what I want you to do is to write a for loop. Oh, and let me say one other thing. When we program, we don't do it on a computer. We don't pull out Matlab and start typing and getting it right. If you do that, you're going to get yourself in trouble. Okay, I've been programming for a decade now. I cannot program that way. I'd mess it up every time. The way I program, the way everybody should program, is with a piece of paper and a pencil. You sketch things out. You try to understand how the problem works. You try to write out the code. You figure out if it makes sense. Then when you're happy with it, you go in and do that. If you do it any other way, you're going to get it wrong. Okay? So if you ever come to me and ask me for help, I would love to help you on a computer program. But the first thing I'm going to do is I'm asked to show me how you did it on a piece of paper and pencil. And if you just tell me, well, all the time I go to the computer lab and I see people just staring at the computer and the keyboard like having no idea where to start. And I'll say, where's your pencil and paper? That's how you program. Forget the computer. Okay? So let's think about what we want to do. Remember, the code, what it looks like is a matrix. It's going to be n by n. And the easiest part is the main diagonal. 2, 2, 2, 2, 2. Okay? So if you want, try to see if you can figure out a very clean and easy way to write that part of the code. All right? Not using any built-in parameters. There's ways to do it built-in. I don't want you to use those. Just try to write a for loop. That's what we're learning about is for loops that would do this part of the code. Okay? So pause it. Come back when you're ready. Now that we're back, this is a matrix, okay? And this is the first row, first column, right? So this is I is equal to 1, this is J is equal to 1. This is the second row, I is equal to 2, J is equal to 2. This is the I is equal to N, J is equal to N column, right? So what we found is that A11 is equal to 2, A22 is equal to 2, A33 is equal to 2, right? All the way to ANN is equal to 2. Okay, and even though this is the ith row and jth column, okay, it's really I is equal to J in all these cases, right? So in general, what I can say is that ith row, and because it's on the diagonal, the ith row is equal to the jth column, so I can say AII is equal to 2. So I'm writing the same where I goes from 1, I is equal to 1 here, I is equal to 2 there, I is equal to n there. So what I'm really doing is I'm saying that for I, so start at I is equal to 1, end at I is equal to n, AII is equal to 2, end. Anybody get that right? Okay, that's it. That's the whole code to write a diagonal. Okay, think about it. It's saying start at I is equal to 1, ends at n, AII is equal to 2. So A of 1, 1 is equal to 2, A of 2, 2 is equal to 2, A of 3, 3 is equal to 2, A of 4, 4 is equal to 2, all the way to ANN is equal to 2, and then we're done. It's exactly what we wanted to do. So let me go back to my main sheet over here. This is my function file. What I would say is for I is equal to 1 to n. I'm going to make, this is going to be a big code, so we'll do n, and I can say right? So that would get my main diagonal term. Now I've got to worry about my off diagonal terms. It's slightly more complicated. So let's think about how that works. So here's our matrix. And so forth, right? So let's worry about what's on the right-hand side here. So we're going to worry about this guy. Well, I should have just pointed to this guy, all these over there. So this is the first row, row 1, column 2, right? That's minus 1. This is the row 2, column 3. This is row 3, column 4, I'm starting to see a pattern here. I was calling it, I'm sorry, some of you might not like this. So I was calling it A here. Maybe I should have been calling it T, because that's what my output is. I hope I didn't confuse some of you, but I could have changed it back later anyway. Called it A and then say T is equal to A, but that's just the way I do it. So we're calling this T, I guess, and so what we see is that the T, the first row, second column is -1. T row 3 column 2 is equal to -1. T 3 column 4 is equal to -1. T n minus n is equal to -1, and you kind of see a pattern, right? So another way of writing this would be T of I plus 1 is equal to -1. Right? If this is I, this is always I plus 1. So this is the main diagonal. Main diagonal. This is the Ti plus 1. And you should have known one other thing. If you do the left diagonal, it's just Ti I minus 1 is equal to -1. Right? And that's almost the whole code. There's one little catch, one really, really tiny catch. Okay, and that is when I get to here, there is no -1 to the right. And there is no -1 to the right over there. So if I'm on my first row, then I don't do anything. So it has to be if I is greater than 1 or something like that. So what I have to do over here is I have to say, this is true if I is greater than 1, and over here you can say if I is less than n, and that's my whole code. Right? So this is an example of a for loop that uses if statements inside a function file, and it does that. So we say so start at I is equal to 1, end at I is equal to n. Okay, do my loop. I've got to do some statements in there, and it'll create my tridiagonal matrix. Okay, and I think I've got that exact same code, although it might not be. Let's see here. I'm going to go into this file here. There you go. So this is almost identical to what I had. Let me, I'm going to call this one tridag 2. Got to name it the same thing, right? So I'm going to call it tridag 2, and then I'm going to move this. I think I had another one in there called tridag. So let's look at this one again. So this is almost exactly how I had it written. Oh, I used a lowercase n instead of a capital N. That's fine. It doesn't matter. I pre-allocated my T matrix, and I said it's got zeros end to end. I didn't have to do that. Maybe we'll actually talk about doing that before. Otherwise, this looks basically the same. I use a little bit different, but if we want to be consistent, I can say, well, if I is greater than 1, if I is greater than n, okay. But otherwise, that's exactly what I wrote, right? That's the whole code. Okay, we can call it if we want to. Okay, let's say I want a 6 by 6 matrix. I don't have to call it T, I can call it B. B is equal to tridiag 2, 6. There we go. We've got a 6 by 6. Oh, I did something wrong. It didn't come out right. I made an error. Let's go look at it. So if I is greater than 1, if I, not greater than n, we want it to be less than n. So clearly an error there. Let's do it again. Now it's right. This is a tridiagonal matrix. It's 6 by 6. I could make it a 4. I could do a 4 by 4, right? I could do an 8 by 8. Do a 15 by 15. Okay. Here's another little trick. The matrix is so big I can't read it all. So if I want to go, I can go to Preferences and change my font. Change it to 8 or something. Now if I do, oh no. If I do that, then I can see it all on the same screen, right? So it's smaller font. Maybe that's too small for you, so I go back and do my preferences. I'll go back to 12. Okay, so here we go. Here's a real code, right? We've got a function file where we had to use for loops and we had to use if statements all in there. You may have done it a little differently. Yours is not necessarily worse or better than mine. There's more than one way to do these things. If you tried to use what's called nested loops, 2 for loops, I think that was probably an inefficient way to do it. You didn't have to use 2 for loops. If you were taking my programming class, then I probably would take off points for it because it's such a poor way to do it. This is the way to you don't want to use more loops than you have to, and so 1 for loop is the way to do this problem. Sometimes you do have to use nested loops, though. Nested loops are loops within loops, and you could have loops within loops within loops if you wanted to, and that obviously can be a little complicated, but that's just how it is sometimes. So here's a case where you've got for I is equal to 1 to n, for j is equal to 1 to m, and maybe you defined a already, bij is equal to 2 times ij plus I. Okay, sometimes that's hard to conceptually understand, but the basic idea is it starts with the most outer loop. So when it says for I is equal to 1 to n, I is equal to 1, okay? And then when I is equal to 1, it does for j is equal to 1 to m. So I is equal to 1, j is equal to 1, I is equal to 1, j is equal to 2, I is equal to 1, j is equal to 3, I is equal to 1, j is equal to 4, all the way to I is equal to 1, j is equal to m. Then I goes to 2, and then it goes through the whole j loop. And if this is a j loop, I is equal to 3, and it does a whole j loop. And then it does that. So that's how the nested for loops work. Sometimes they're necessary. Okay, but you should understand how a nested for loop works. Okay, moving on to while loops. While loops are, again, go back to my analogy with running around a track. So when you run around a track, a for loop was when I said run 10 times around the track. A while loop, the way it works is I say run around the track while some condition is true. Do it while the time is under 15 minutes or something. So it's not necessarily a set time. And to give you an example, this is how it looks right here. And notice a different notation. So in this case, I say, x is equal to 1, right? Or x is equal to 1.0, something like that. X is equal to 1. Continue to do a loop while x is greater than 0.01. Now, here's another mistake I see people make, and it's another mistake that I know people, they don't know what they're doing in terms of programming. I'll see people put while I is equal to 1 to n. That doesn't make any sense, okay? It's wrong, okay? You do for I is equal to 1 to n, or something like it. You do while some condition is true. So do it while x is greater than 0.01. In this case, x is equal to 1, so you define what x is in advance, and it gets to this line here, and it says while x is 0.01. And it asks a question. It says, well, is x greater than 0.01? It is. 1's greater than 0.01. So then, do the commands inside here. And so it says x is equal to x divided by 2. So what would that be? X divided by 2 is 0.5, right? 1 divided by 2 is a half, so it's 0.5. Then it comes back to the start of the loop, and it sees if 0.5 is greater than 0.01. It is. So 0.5 divided by 2 is 0.25. Then it's 0.125. Then it's 0.0625. And then it continues to do that until it's no longer true. And I'd like to make one last point about this, is that if it drops below 0.01 inside the loop, that's okay. It still does the command. It's just that when it checks it the next time around, it doesn't do another loop. So let's say it starts this and x is 0.011. And then it says, well, that is greater than 0.01. So then it divides it by 2, and 0.011 divided by 2 is what? 0.006. And then when you finish it, it's going to display x is 0.006 or whatever that's going to be. And because it actually did the command in there. It's just that when it gets back to the top and it checks that condition is no longer true. Here's another analogy, right? So you're running around a track, and I say, run around the track while the time is under 15 minutes. Well, but let's say you only check your clock at the beginning, at the start line. So you run around the track, and you check your watch, and you finish one loop, and it says 14 minutes and 45 seconds. And I told you to run while it's under 15 minutes. Well, you're still under 15 minutes, so you start the next loop, and you finish that whole loop. And then you get to the end line, and maybe you get to the end line, and it's 17 minutes. Then you quit. But you finished that loop. You did everything. You ran around the entire loop because you didn't check your watch until you got to the end. The same thing works here with a while loop. Okay? If x is 0.011, it still starts it, and it does the command, and it does anything that's in there, and it saves anything that's in there. It's just that the next time around, if it's below 0.01, then it doesn't do it anymore. Okay? So make sure you understand that. We can do an example. We can do that same example if we want. Okay. Probably be a good idea to do this in script file, especially for you if you want to practice. But x is equal to, oh, I really wish the, so we could say x is equal to 1, and then I could say while x is greater than 0.01, x is equal to x divided by 2, and if I display x, it's going to be less than 0.01, right? So obviously, what was what is x times 2? Nope. So x was 0.0156. And which was greater than 0.01. It entered the loop. It divided it by 2. It got to 0.0078. That's what x now is. But then when it checked to see if it was greater than 0.01, it wasn't. So that's how you can do. That's how the while loop works, right? Now I'll say one other thing, in that let's say I did the same thing, but instead I said while. Let me do the same command. While x is less than 0.01, and I say x is equal to x times 2. What's going to happen? It is never, that while loop is never going to end. That loop is never, ever going to end. Because x is always going to get bigger, and it's always going to be greater than 0.01. So if I do this, well, oh, I should have said x is equal to 1. Okay, and you see, x just keeps on getting bigger. It's 1, then it's 2, then it's 4, then it's 8, and it just keeps on getting bigger, and it's going to run forever. The only way to stop it is if I use the Control-C. Because, if I ask it, x is equal to infinity, right? So x was just kept on multiplying and became infinity. So, you got to be careful with while loops. One way I could have fixed that There's a few ways I could have fixed it. One of the things I could have done is I could have said while, well, I could have done a counter. So what I can do is I can count, I count is equal to 1, right? And I can say while x is greater than 0.01 and I count is less than 100. And then I can say x is equal to x times 2. And I can say I count is equal to I count plus 1. What it's doing is it's just counting the number of iterations I do. And I can end it. And okay, and then it does it, and I can see I count. Okay, when it got to 100, it said, wait, cut it off, okay? Because it's still greater than 0.01, but I count isn't less than 100 anymore. And x, x got to infinity because I kept on, you did that, so you do the math, but you get to wait, it gets bigger than the machine precision, so that's why it's infinity. But I could have done, maybe I should have done, oh, it's still too big. Okay, but you get the point. Well, I should have. That's because I didn't redefine x. Well, you get the point. So that's while loops. Make sure you understand those. Something we'll use in my class and other classes. The break command is not something I use very often. Okay, but break is a way to break out of a loop. All right, and so that's another way to kind of get out of a loop if you want to do that. Here's a case where I say for I is equal to 1 to 5, and then I say if I is equal to 1, if I is equal to 3, then it breaks. So it just comes out of the loop. I don't use break commands very often. It's another thing you can do with a while loop. So if you're worried about getting in an infinite loop, you could do a break. You could say if I, while x is greater than 0.01, but then you could say, and you can do your counter, I count, and you can say if I count is equal to 50 or greater than 50, you could say break, and then it breaks out of the loop. So that's another way to do that. I don't use break commands very often. Maybe I should, but it's another kind of tool you can use within loops if you feel necessary. So I think that is going to end this part of review. So the next session, so in summary, we did function files and script files. Make sure you understand the difference. They're both .m files, but function files are called. Script files you run. All function files you start with the word function and write it. Then we learned some different types of techniques. We learned if statements, or more specifically, if, else, end statements. Then we learned for loops, nested for loops, while loops. By the way, you can have a for loop within inside a while loop, or a while loop inside of a for loop, or a for loop within inside a for loop inside of a while loop. There's nothing that says you can't do that. We might do an example of that next time. And then, we did the while loops, and then we mentioned break commands, and that's kind of an overview of some general programming techniques. This ends this part of the review session, and we'll have a couple more after this. Thanks.